Welcome back to my channel. I'm Brian Kapke, and this video, what I'd like to do is dive into the progression over time in the core features, trends, roadmap, and directions of what Databricks and Apache Spark have been doing. And my goal in this is to really shore up a lot of what I talked about in my extensive series on Apache Spark with an understanding of how things have changed, and most importantly, how confusing it can get, and demystifying all these terms and what's really going on. And a little bit of history can't hurt in that regard. So let's jump in. Where are we going? We'll talk about what is Apache Spark and what is Databricks, just to give you a sort of starting point. Why is it so confusing? And we'll talk about Apache Spark's evolution, and that will lead us into takeaways, what you need to know to really sort of understand and sort out this very large ecosystem of services. So what is Apache Spark? It's an open source big data platform for data analysis, and it's the most popular open source platform, I believe, on the planet for doing that. Big data now means challenging data, not just massive amounts of data, although that is part of it, but it involves things like streaming data, unstructured and semi-structured data, images, video, and sound, as well as structured data, which is also a good part of it. Now, Apache Spark does give you this sort of basic functionality of massive scale of processing data, but it doesn't give you a lot of tools to do it. There's no orchestration and many other things that are missing. So that's one of the sort of downsides of Apache Spark. You can bring your own tools, and there are many in the ecosystem. There's very weak support for collaboration. So Apache Spark is kind of like you create all this, you install it, and then you bring up your cluster. And it's not designed really to manage like hundreds or even more than one cluster at a time. So if you've done, for instance, HD Insight, typically you'd create a single cluster at a time, and when you're done, you have to physically delete it. And it is not optimized for the cloud. And this is something that I remember when I was at Microsoft as a big selling point, if you will, for Databricks, which is optimized for the cloud. Apache Spark was developed and intended for on-premises deployment and maintenance, and so it's completely cloud underwear, and there's no optimizations for that. So when you run open source Apache Spark on any of the major clouds, you're going to find you're not getting optimal performance for that environment. So what's Databricks, Brian? Databricks is a commercial product from those that brought you Apache Sparks. So the authors of Apache Spark decided, how do we make money off this basically? How do we monetize it? And so they came up with this company called Databricks, and their product is also called Databricks. Databricks is a complete cloud-based development environment for Apache Spark, and it currently is available on AWS, Azure, and Google Cloud. Keyword here, cloud-based. It is not something you can run on-prem. It has numerous proprietary Spark enhancements. What do you mean proprietary? I mean they're Databricks secret sauce. They're owned by Databricks, and they're not released to Apache Spark in general. A lot of things are released, but there are still things that make Databricks sort of perform better. It's ideal for data science and AI team collaboration. Databricks, from its inception, and of course Apache Spark, has really been about AI. That's kind of what it was always designed to kind of help you do, data science, AI, model training, in addition to all the analysis. But Databricks gives you a lot of tools to support collaboration and really development in many different forms. It has a lot of added services and development tools, and that's really the core takeaway. Like, why would I choose Databricks over Apache Spark? It's a very comprehensive solution building environment, and it is optimized for the cloud. So you're going to get better performance using Databricks than you would Apache Spark on the cloud. Now we get into the fun stuff. And I put this from Hitchhiker's Guide to the Galaxy. Don't panic. What do you mean, don't panic? Well, it's not you. If you're jumping into Databricks relatively recently, then you're probably like, oh my gosh, there's so many tools, and every week they're coming up with something new, and they're adding this yada yada and that yada yada. It's not you. There really are a lot of different services being added all the time, and they keep giving them a new name, which makes it even more befuddling, right? Like Delta Lake and this, that, and Delta Live tables. It's really kind of baffling. So I want to talk about why is it so baffling, and to understand why Apache Spark has changed so much over time. You need to understand that when Apache Spark was released, it was a massive improvement over the other solution out there, which was Hadoop MapReduce, which had a lot of different design features. I'm not going to get into that, but when it came out, it solved that, and Spark performed up to 100 times faster than Hadoop MapReduce, and that's really all their goal was. It had a lot of initial limitations, and I think Spark was just released a little too quickly, but the idea was to get it to market as soon as possible, get it out there. Now I say MVP, which means minimal viable product. Get the core thing out there and you can enhance the heck out of it later. And of course, that's a very agile approach. So let's talk about the limitations. It's built on the Java Virtual Machine, the JVM, and that has a lot of constraints and problems which initially weren't an issue because it was still 100 times faster than the other competing solution. But now people are looking for something faster and faster, and the data is getting to be more and more, and speed and memory issues related to using the JVM have emerged. Apache Spark is written in Scala, and the primary API when it was released was Scala. Pretty much the only API when it was first released was Scala. No support to update data. In fact, if you're as old as I am, I got into Databricks when I worked at Microsoft, and it was just released when I started Microsoft on the Azure platform. And I remember everybody saying at this time, we don't need data warehouses anymore. Let's just throw data onto the data lake and we can slice and dice and we're done with all that curated data stuff. That's too much work. Well, it was too soon to say that. And this lack of ability to update data, which may surprise you if you're not aware of this sort of history, became a really limiting factor. And Databricks had to solve that within Apache Spark. No SQL support initially. The base data structure at the time was called the RDD, which is a resilient distributed data set, and it's really hard and unintuitive to work with. Limited support for Python and R, very limited initially. No central data management. So we all see these things now that are cataloging our data and showing lineage and everything. There was none of that in the first release of Spark. It was just dump your stuff in the lake and go at it. Very limited streaming support. So let me talk about the lack of the ability to update data, because again, this is something I think people missed. I missed it initially until I started getting into using Spark. So you have this thing called a data lake, and a data lake was around with Hadoop MapReduce as well. In fact, the underlying sort of virtualized, we'll say, file system called the Hadoop distributed file system, when you copy things into it, it's like a drive. You just say, hey, copy things in here and you're good. But when you copy things to HDFS, as it's called, it actually splits it up into chunks and distributes the data over multiple machines. So it supports the multi-parallel processing that you need by chunking up the data at the very beginning. But it's obscure to you. You don't actually see that. You just see files and things out there. And that is known as the data lake. It's really nothing more than like a file share. It's like a D drive, if you will, or an X drive, but it's distributing the data. Now, HDFS is still the underlying virtualized storage system used by Spark. So when we think of the data lake, we think of something called schema on read, which means you bring in CSV files, Parquet, whatever it is you're bringing in, and you define a schema for it. So for instance, if you bring in a CSV file, you could have the first row define the column headings and have it dynamically figure out what the types are, which is typically going to be like a lot of strings. Or you could, for instance, pass it a descriptor that says this is how you should read it. Now, the initial version of Spark really only supported RDD, so you didn't really get this. But as they added SQL support, they also allowed you to define what's in your files. So whether it's JSON or CSVs, there were ways to describe the data, and then you could treat it like it was an actual file. So you could select and do the SQL type of thing on it. And this was only after Spark 1.0 and above, but you could do that. However, you couldn't update it. So let me kind of walk through what the problem was. You got someone coming in and saying, we want to bring some data into the data lake, and so they bring some files in. And nobody else really knows what these files are, but they decide to dump it into the data lake and start querying. Another group comes along, and we'll say they're in finance, and they decide they're going to bring some financial spreadsheets down, and whatever they have, they dump things into the data lake. Another group does the same thing, another group, on and on. And what happens is you have a problem because people don't know what the data is. Remember I said there's no catalog, there's no tracking. So you've got all these files sitting out there. They're not being maintained because there's no way to insert, update, and delete rows. So you can copy more files in and delete old ones, but you don't even know what this data is. You don't know if it's current or it's accurate. You don't know where it came from. You don't know why potentially the values in it are wrong. And you don't know how do you get the information you need. So you come along to this data lake and you say, whoa, do I have to get the data myself, or is there data out there I could already use? You don't know. And has somebody already done this? Kind of the same question, but do I have to reinvent the wheel, or has somebody already done this? So what happened was we ended up with what's called the data swamp. And the data swamp is the very reason why the lakehouse came into being. It was to deal with this problem. So again, the problem is you can only read the data in the beginning. Now I'll add one thing. Could you extract it? Could you read it in and create a new file, like extract part of it and dump it out? Or maybe pull two different files in and by doing some merge and write, simulate updates? You could, but it was a lot of work. And you can imagine you're dealing with a lot of data coming in. So creating these kind of, rigged systems where you're simulating updates is really unmaintainable. So along comes the data lakehouse. And I'm bringing this up because it's a really pivotal change that's defined a lot that came after. Data lake, right? The data lake that we just saw, that was already there. But the need for a data warehouse came into being, right? People realized, oh my gosh, we kind of jumped ahead of the game and said, we don't need data warehouses anymore. Yay us. It's so much easier in the BI side not to have to worry about that. But then you don't have the ability to have curated current data. So Databricks came along, and again, they are the primary maintainers of Apache Spark. So they pretty much decide what goes into Spark and what doesn't. And they said, we need a lakehouse, something that can take what the data lake does, combine it with a warehouse functionality, hence data lakehouse. So this is really important and pivotal. We're going back to now the more traditional kind of idea and concept or paradigm, if you will, of the warehouse, but it's on a scaled out platform, i.e. Apache Spark. Now the technology under this, and this is why it's so important, because you've probably heard of Delta Tables, Delta Lake, Delta Files, but they call it Delta Lake overall. Delta Lake is more or less synonymous with Lakehouse. However, Delta files are the maintainable files, but you'll have lots of files you put in there like CSV, and files you're not updating, maybe they're input to your Delta Lake. So that's why they have Lakehouse. It can include Delta format files, but it can also include a lot of non-Delta files, so it's a Lakehouse. All right, now that you understand that, I want to talk to you about a lot of other things that affect the terminology and the things you need to understand when you use Apache Spark. In the lower left-hand corner, I want to sort of highlight the fact, you can see here, that Databricks was released in AWS in 2014. That's not that long ago, right? 10 years ago. It was released on Azure when I started in 2018, and then it went to Google Cloud. So Databricks is not owned by any cloud company. It's not owned by Microsoft or any other company. It's owned by a company called Databricks. And you can see that it was released on different cloud environments over time. It is not in other cloud environments at this point, but it could be added because it's kind of portable, I guess. So let's look at the timeline. And you notice in here, I'm saying there's a balance between Databricks and Apache Spark features. The challenge of giving you an Apache Spark timeline is that Databricks adds features which may or may not end up in Apache Spark. It's pretty clear watching Databricks, they try to put as much as they can in what they develop into Apache Spark, but some of their services are so value added and so extensive, for instance workflows, it would be very difficult, I think, for them to throw it into Apache Spark. So they don't tend to do that, but the core engine features they tend to put in there. So let's walk through this a bit because I find it kind of interesting, and I think you will too. So Apache Spark was released, the first release, 0.8, right? So 0.8.0. It was a Scala only environment. So you had to use Scala, and it was written in Scala, right, which is a sort of derivative of Java, and underneath the covers it uses the Java virtual machine. It runs on the JVM, and it supported only this thing called the resilient distributed data set, which is something that similar to what you would do in Hadoop MapReduce, in that you would have to do this sort of parsing and aggregating called map and reduce, and that's how you queried it. It was not intuitive. It was hard to write complex queries, if you will. It was fast, but it just had a lot of problems. And by the way, the RDDs could not be optimized because even to the underlying system of Spark, it didn't really know what you were trying to do. There was no code you could kind of parse and figure out what was the goal. 2014, and mind you, this is 4 years later, Spark 1.0 is released, and then subsequently 1. Yada yada until I'm going to roughly say 1.4.1. So I want to talk about the features. SQL, structured query language, was added. Now mind you, everyone's saying we don't need that anymore. Fortunately, a guy named Michael Ambrose, at least, he talks a lot about this, and other people at Databricks said we need an intuitive language, something that you can query in an intuitive way that's understandable, because not only is it helpful to the users, but if you use a code that is interpretable, you can understand what you're trying to do, then it can be optimized so we can make it run faster. And so the Catalyst Optimizer was added at the same time with SQL. PySpark was added. PySpark can interact with the SQL service. In fact, SQL is really an API that can be interacted from other languages very easily, which is really nice. So you can use structured query language from within Python, and you also have the PySpark API. which supports the legacy RDD, but it supports a lot of more things. And so it's a really important shift. And what I put in orange here is to highlight what I consider to be really important changes that drove the future direction of Apache Spark. Now, all of this happens at the same time as adding the data frame API. You've probably used Python Pandas data frames. It's like an in-memory table, right? You can slice and dice. It's got columns and rows, and it's extremely intuitive to use compared to the RDD. It's a lot easier to use. It's also something that is far more intuitive to people who have used R and Python and they're familiar with data frames. This is a Spark data frame, so it's scaled out, but it allows you to do similar things. So this is a big shift. Not only do you get the benefits of the data frame, but because of the SQL optimizer there, which also works with data frames, it will be able to optimize your queries. You also got Spark R. I don't know that that's as big a change, so I put it in white as opposed to orange because I don't think R is really a huge programming language on Spark at this point. And you got MLlib, which is a scaled out machine learning library, a GraphX, think of like sort of a network node edge kind of thing, interface, and also a streaming API. So this is a pretty big period. Mind you, it's only around this time that Databricks was released as a service on AWS. The first time Databricks actually gets released is around the same time. So I'm kind of jumping ahead a little bit to major changes down the road, which is from 2019 to 2023, Spark 3.0 and above are released. And we can see the most important one I just described is Delta Lake. The inability to do updates and kind of simulate relational database tables is really felt strongly in the community, and Databricks knew this would be a problem, and they're already working on a solution which we call Delta Lake, which is built on Parquet files, but by using logs and things behind the scenes, it's able to do a lot more. I'll put a link in the description to my riveting presentation all about Delta tables and Delta Lake, and you can get a better idea how it works. The most important thing to understand though is now with Delta Lake you have Delta tables which act a lot like relational database tables. You can insert or create, you can read, you can update, and you can delete. So you can maintain tables. However, I will point out it's not truly relational database tables because Spark is not a relational database platform. They also did something which drove the future of what they would do, and they've been working on this all along. A goal of Databricks has always been to make the optimization and execution of your queries as fast as possible without you doing anything to make it happen. Now, this clearly didn't happen in the first release, 0.8, but they started working on that as early as 1.0 when they added the Catalyst Optimizer, which looked at your SQL or your data frames and would find ways to optimize it. Well, this got massively expanded in a lot of ways that I won't even talk about here specifically, but the Adaptive Query Execution Engine is a really interesting one. There's something very similar in SQL Server in which you run your query. It looks at the query execution before it actually runs it. It kind of does like a trial run and says, that didn't look so good. And it analyzes how it approached your query, and then it tries to find a way to speed it up. So it'll actually rewrite the query execution plan several times potentially before it actually gets to what it runs. And this is really important. The other thing that happened in this time period is Python took over the world. I think Python is the most popular programming language on the planet. I'm going to go with that. People can disagree, but it's just become such a massively popular language for a lot of reasons. Databricks knew this, and so they shifted a lot of focus to Python, and I'm glad they did because a lot of people don't want to learn Scala, and it's not the most common language used, especially in the data science and data engineering world. So they went to a Python first approach. What do you mean Python first? Well, I'm not going to talk about Delta Live tables too much, except that that was kind of an example where they went with SQL because that's primary and built into Spark, but they also made the API for Delta Live tables Python first rather than Scala, and that was a very strong indication of just how much they are emphasizing Python. They also came along with optimizations that weren't just specific to Python like Apache Arrow, but certainly helped it a lot, right? Pandas API. What's the Pandas API? Well, if you are used to using Python and doing any kind of query analysis, you're probably using the Pandas library, right? So you're using data frames within Python. However, Pandas data frames are not cluster aware. They only work on a single machine, which is a problem if you try to take your Pandas code and then just run it on Databricks. The PySpark API requires you rewrite the syntax and everything so that it matches what Apache Spark requires. With the new Spark Pandas API, you could just swap the library out and it would support the Pandas syntax. So you don't have to rewrite code. And that's been another place where Databricks has spent a lot of time trying to make it easy to take your code and move it to Spark without any changes. Also trying to minimize the amount of learning you have to do when you already know Python and you move to Spark. So again, the key thing I want to take away from here is optimizations are being focused on a lot, making things faster and faster without you having to do anything. Also, Python's become really, I think, the hottest, most important language on Apache Spark. SQL works with it, and I'll talk about that too, like it's important, but Python really is becoming critical because it supports many different ways of programming that SQL can't support, like looping and creating functions or creating classes and things you can do in Python. So let's jump ahead a little bit to 2024. What do I say there? Well, Unity Catalog was open sourced, and I was a little bit surprised by that because it just seemed like something that was really sort of Databricks specific, but they open sourced it. And the idea now is that you can have a central data catalog. So what do we have before, Brian? What we had before was something called a Hive catalog, and the Hive catalog was specific to really a cluster on Spark. So you have this cluster running, and then when you store things, it's limited, right, to that particular environment. In Databricks, the Hive catalog was restricted to a single Databricks workspace. And the problem is that when you're working in a company and you're setting up something like Databricks, you probably have a Databricks workspace separate by application, like this is finance, but then you're going to separate it again by environment, like this is dev, this is QA, this is production. So you can end up with a lot of different workspaces. This itself can be a management issue for Databricks when you're in a company, because it isn't really well designed in terms of scaling out in terms of environments. Unity Catalog solved a major part of this problem, which is now you can share your data any way you want through the Unity Catalog. Hive really was restrictive in that way. There may be future changes related to the workspaces itself because they tend to be difficult to share across, say layers like dev, prod, QA. There's things they call like secret keys and things, and I think you have to be really careful if you decide to use one workspace to do multiple things. That's why it tends to proliferate a lot of workspaces. And so that's what Unity Catalog is about. Unity Catalog is now a standard feature. I'm not really sure how popular it is being used in Apache Spark, but I would recommend anyone who's trying to learn Databricks and Spark know all of these tools. And hopefully this is helping you give the context. I'm going to talk a little about AI, but the most important thing I want to emphasize with AI is that AI, machine learning, data science, that has been sort of at the core of Databricks from the very beginning. And it's not surprising. They've done a lot of investments over the last couple of years, buying companies, buying tools and services and integrating them. Apache Spark is probably the best environment for developing machine learning models and doing AI. That's my own personal opinion. I'm sure Databricks would agree. But it just, because it was well designed from the beginning to suit that purpose, and its excellent support of Python just adds to that, because Python is an excellent language for doing AI, right? So what's in the future, Brian? What do you see happening? So I'm going to do this as a sort of guess, which is this product called Photon. Now currently Photon is not open source, but what is Photon? Well, I mentioned that this idea of getting faster and faster execution has been an issue from the beginning. It's something Databricks is constantly working on. I also mentioned that the JVM has been a problem because Scala is the language that Spark is written in. Photon is a really revolutionary change that's kind of quietly entered the Databricks and eventually I think Spark environment. Photon is a complete rewriting of the Spark engine. Now I say complete, I think eventually it'll probably be complete, but at this point they've taken big chunks of the Spark engine and converted the code to C++ because it's faster, it has less memory issues and yada yada yada. It's just a better language to use if you want performance. However, Photon is not supported by all languages. It supports Python, which is great. So they've got issues with that they have to deal with. They're also trying to maintain dual support so that it still works with code that requires the JVM, but when it can not use that kind of code and use the rewritten C++ modules, it will do that. But it's getting massive improvements in speed. I believe Photon will eventually be open sourced. If for no other reason, then it's going to require maintaining two different code bases for Spark if eventually Databricks doesn't release it as Spark. In other words, they'll have to maintain the Databricks version of Spark and the Spark version of Spark. So I don't think they're going to want to do that, but that's just my opinion. It also is a question of, will they continue implementing more Photon and rewriting the engine? And I tend to think they will, because it just makes a lot of sense to get that speed improvement. So let me review the takeaways we have here. 1, stop worrying so much about performance tuning. When I started with Databricks and Spark way back in the day, that was a huge issue, and people mostly were focusing a lot on Scala and what you could do with Scala to improve performance, and then it became Python tricks and everything. But with all the things that Databricks is doing, and they're moving to Apache Spark to improve performance, this is becoming less and less of an issue, especially on Databricks. So don't worry so much about it. I started my own series on performance tuning on Databricks, and I'm going to continue that. But every day you wait, they improve things so that it automatically takes care of itself. Go Python, then SQL. In other words, you need to learn Python on Databricks or Spark. I recommend it highly. When you need SQL, then use SQL. And the nice thing is you can do like a Python query that calls the SQL engine and does a query and returns a data frame, a Spark data frame to Python. So it's a really nice combination. And of course, when you want to use SQL, go ahead. It's great. If you're primarily a SQL person coming to Databricks or Spark, then by all means use it. But I would recommend that you try to learn as much Python as you can, because you're just going to get more control and functionality with Python. Avoid using Scala. Now, why is that? That's what it was written in. As you've seen, it looks to me like Databricks is going to move away from the Scala language. They haven't really improved the API as much as they have Python. They're kind of limiting what they do with Scala. And frankly, it's just not, I don't think it's the right language to be using in data engineering when you have Python. This is something a lot of the older people using Spark will disagree. I've disagreed with people and like, no, you got to use Scala. You got to use Scala. I think it's less of an argument now that we've gotten into the more advanced tooling and Python support, but it still will be there, and you may encounter this, for instance, in interviews. Bear in mind, when you're using Apache Spark or Databricks, there's an opportunity for open projects integration. So I want to bring that up because sometimes people forget that. Now, as a contrast to, say, Snowflake, Snowflake was not an open source project. It is not an open source project. And the integration of open source projects into it, I'm guessing, is not going to be necessarily as easy. But Spark is actually part of the open source projects community, if you will. And so a lot of things will integrate with it. And that means you could bring in other tools like, I want to use Great Expectations for data quality, or I want to use certain open source machine learning models. No problem. It supports a wide range of model training options, open source and within the Spark environment itself. And if you're on an environment like Azure, you can even use the Azure ML features and models. So as I mentioned, Spark is an ideal platform for AI and machine learning. Hence, I think it's going to grow even more in popularity. Coming back to the original statement, it's not you. There really are a lot of services and features. I hope that this kind of walkthrough of how they evolved and why they're there helps you. The important thing to understand when you see something like, what's this Delta Lake and why is it so confusing, for instance, is they need to distinguish Delta Lake from the traditional just dumping files and not updating them. So they came up with the idea of a lakehouse, and then they have Delta Lake and a lot of other terminology, and it gets confusing. And I've only talked about a few of these things, so it is confusing. My advice is just take one thing at a time and build up. Wrapping up, we talked about what is Apache Spark and what is Databricks. The main takeaway is that Apache Spark is an open source big data platform, very performant, that was written by the company founders of Databricks. Databricks is a company created, I think, to monetize Apache Spark really for the people who wrote it. And it uses Apache Spark as the core engine, but it is completely cloud-based, runs on the 3 major clouds, and has a lot of development features around it. There's a big difference between the two. You can think of Databricks as being kind of this comprehensive luxury hotel room where you get everything you need, and Apache Spark is more like you've got a tent, you got to set it up, and you're not getting a lot of other features. Why is it so confusing? Well, I hope I've explained that, just looking at the history of it and the fact that Spark came out with a lot of things lacking, and that implementation of filling out those problems and limitations has caused a lot of new terminology and a lot of new services, and it gets confusing. So we talked about Apache Spark's evolution, the limitations of Apache Spark, and how those limitations were eliminated over time. And that's really where that sort of timeline comes in, because you can say, oh yeah, here's where they introduced this to solve that problem, and here's how they did this. And it continues to happen. Databricks is working feverishly all the time to add new features, and sometimes it's actually kind of against them because it gets overwhelming for developers. Like, oh no, that's what we did 2 days ago, that's old hat, and it gets really a little overwhelming. It's like, wait a minute, this is what I thought was how you do it. So the takeaways is what you need to understand. I hope this has helped you, and go back and look at these things. I'll put a link to the slides so you can get those for yourself, and put comments, ask me questions, hopefully relevant to this. Sometimes I get questions that have nothing to do with this, but hopefully relevant to this topic. And until next time, I'm pulling for you. We're all in this together. Thank you.